You gotta leave for
Okay.
band.
What do you do? Huh?
You gotta leave for band, didn't you?
Yeah.
Alright, so here's the deal with chapter 10. We're still in this big trig section, 2 more chapters of trig. This one is about trig functions, and our functions are like how these functions are represented graphically. So this is going to be the chapter on like how to graph trig functions. So you know that wave, and so today we actually start with talking not about a specific trig function, but about just periodic behavior. So some of the basic vocabulary words that we need to know as we move forward. And then we'll talk about sine the rest of this week. Cosine and tangent will be next week, and then we'll have a section where like everything's all together. And we'll have like all the different stuff. Go ahead and write your staff X. Everyone got the title? Okay. So here are a lot of vocab. Like I said, a lot of words we need to know as we move forward here. So a periodic function repeats itself over and over again in a horizontal direction in intervals that are the same length. So I have a wave here, and we can see it's the same pattern up and down, up and down, up and down, moving horizontally. And these are all about like the same width, right? So they're all the same width, the same length, getting from one side to the next. Yep, we'll get into the actual functions tomorrow, but this is just all the basic stuff you need to know. So the period is the length of one repetition. So let's say we start here at like on this line, going up, down, back up. This section is like one period. And then that same shape keeps repeating itself. So the period is just like one rotation, one repetition. I don't know, I like to say rotation because I feel like it's that cyclical, it's going over and over again. So the period's a really important word. And again, I know you guys have graphed these, so some of this is definitely should be reviewed, but like I said, this tends to be a chapter that students perceive as being tricky. Another really important word is, well, a phrase is principal axis. So principal axis is the horizontal line in which the wave oscillates. You can see it's labeled on this picture here, but it's the line that's like in the very middle. It's definitely exactly the middle between the very top and the very bottom, and we'll get proper terminology for that, which I'm sure you guys already know as well. But that principal axis is directly in the middle, exactly halfway in between, which is how we get this formula here for principal axis. So it's a y equals a number, because those y equals a number lines are horizontal, and you take the minimum value and the maximum value and divide it by 2. So wherever the tip top part is and the very bottom part, the maximum and the minimum, you take that average, you add it up and divide it by 2. And you'll have a principal axis when we talk about sine, cosine, and tangent. Well, you will for tangent, but tangent will be a little bit different than the minimum and maximum. But for sine and cosine, you can get the minimum and maximum and add those up. So we do have some more terminology to talk about. How are we doing? Can I move on? All right, so more more vocab, and you already heard me use some of these words. Our maximum point's the top of a crest. So the top part is the maximum. The minimum point is the bottom of a trough. We're using some wave terminology here. So we can see we've got the maximum and the minimum on our diagram. And then this is a really good, a really important word as well, is the amplitude. So the amplitude is the distance between the maximum or minimum point and the principal axis. So it's kind of like from that middle line, the principal axis, how high does the wave go? Or to the minimum point, like how low does that go? These are going to be the same length, remember, because that principal axis is exactly halfway in between. So that's the amplitude, is this distance. It's kind of like how high or low that wave is going. And you can find the amplitude by this little equation here. If I take the maximum point minus the minimum point and divide that by 2. So make sure you guys have those written down correctly so you don't have the principal axis and the amplitude equations mixed up. Are these words familiar? I mean, minimum and maximum, I'm sure you guys know, but like period, we talked about on the last slide, and the amplitude. Familiar words for you guys? What about principal axis, that line down the middle? Okay. So today being the first section, what we're going to take a look at is just like looking at random data and then trying to decide if it's periodic or not. And then if it's periodic, can we figure out what is the period? What is the principal axis? What is that amplitude? So the next slide should be our example, and it's just going to be like a bunch of numbers. So I wouldn't recommend writing them all down, but trying to graph them instead. Well, I forgot to point out that the period is marked on this diagram as well. All right. Oh, stop X, I forgot. Oh, stop and act. We haven't had one of these. So make a wave with your hands. Imagine where the principal axis is, the amplitude, the period. So just so you kind of can get that. I forgot that this is happening. So we've got, the maximum, minimum points. That principal, I'm not going to be able to do two hands, but like down the middle is the principal axis. That the period is how, like if I'm going up, down, back up, that's my period. The amplitude, the height there. So it's a proven strategy that by like actually moving your body, that will help you remember those things. So that's just another strategy. I have to remember to use that strategy with my freshmen more, I think. Okay, so I would not write this all down. Remember that I will be putting this on my Google Classroom and on YouTube, so if you want to write down the data later, you can. So we've got the average monthly temperatures from 2012 and 2013. So the months are starting at 1 and going to 24. Because we've got January through December of 2012, and then when we started January, we had to go to 13. And so to sketch this, now I want to try and do this really carefully. because I'm going to try to leave my picture up. So we'll have the months going across on the x-axis, and then the temps on the y-axis. And so I think I just decided to do my temps by like counting by tens. So like, I don't have lines. You guys probably have lines, so you can make yours look a little bit nicer. And then across the bottom here, we'll have all those months. Uh-oh. I'm just barely fitting all of mine on, so hopefully you guys can do that. And then we'll graph these. So like at 1 month, we're at about 32. So obviously we're going to have to estimate a little bit here. We'll go ahead and graph the data. You guys can see over my head, right? Like am I blocking it? Okay. I didn't think so, but I was like, well, I am standing directly in front of it. But thank you. I'm glad that you guys can see.
Perfect height to teach math.
Alright, so you guys have a couple more minutes to sketch that out. Okay, so what we're going to do after we graph this is we're going to see if we can figure out the period, what's the principal axis, and what's the amplitude. So before I kind of go to the next slide, what do you guys think the period is? Like how many months do you think pass before we start making that same pattern again? About 12, kind of, so we kind of start low, we go up, come back low. Low, up, back, low. So looks like our period is 12 months. So that's the first question. Oh, actually, the first question is it periodic? Do you guys think it is periodic? We sort of covered it, right? Yes, because it's like we already said, low, up, back, low. So yes, it's periodic. All right, so then what's the period? As we said, it looks like it's about 12 months. So like from, the first month to the 12th month, that sort of pattern is repeating itself. Now this is real data, so it's not exact, and we'll talk more about that actually on Monday when we fit our data to sine curves, but that'll be a little bit later. So this is kind of hard to get from the graph, but when you guys do your assignment, you'll have like the chart in front of you with all the numbers in it. So remember, the principal axis is when you add the maximum and the minimum and divide by 2. So the maximum was 79.5 and the minimum was 32. So again, I know it's hard to get from my graph, but you'll have your charts in front of you. So then I end up with 111.5 divided by 2, which is 55.75. So remember, that's actually a line, so I'm going to write that as 55.8 for 3 sig figs, and it's like an equation of a line. So that means at 55, that should be like down the middle of my graph. Now, I know it's not perfect because I don't have the lines, but that's pretty close, right? To being down the middle. So that's my principal axis. So we talked about the period and the principal axis. Then remember, for amplitude, we have to subtract those. So it's 79.5 minus 32 divided by 2. So 47.5 divided by 2, 23.75 or 23.8. So that is like the distance, remember, from the top down to the principal axis. That's our amplitude. So that's about 20, let's even just say 24 for right now. So look at 24-degree difference from like where the middle is to the top. And this should be the same. Again, I think mine looks a little off because on the smart board. Hopefully yours is a little bit closer. And the principal axis is slanted. So mine looks a little off, but if you guys want, you can pull out a straight edge or what have you. Okay. The assignment is pretty short for this first section. Again, it's you can really understand period, principal axis, and amplitude, because then we'll start applying it to trig functions tomorrow. Are there any questions before I erase this and put your assignment up here?
Just skip chapter 10 and do ACT prep stuff.
Well, I do have to get you through all the material I have to get you through. All right, so I feel like today you guys should be able to graph your sketches in your notebook. I will let you know that starting tomorrow, I will have some like optional trig graphing paper. So I'll have like sheets of this. Starting tomorrow, when we start actually graphing trig, you're not going to be required to use the graph paper. Like if you want to do it in your notebook, you can. But I'll have some, and then if you can like maybe do more than one assignment per sheet, because it's going to be a lot. I think we're doing a total of like 3 or 4 for the chapter if we use this.